Alright, so let's go ahead and take a look at another argument here. First thing I want you to notice is on the last video I forgot these parentheses, okay? It's not a big deal. These parentheses really don't serve any purpose. It's just kind of a cosmetic feature that this textbook uses that not all textbooks do. I actually kind of don't like it. I think it just kind of crowds things, okay? But they're not like these that serve an important purpose in showing what the scope of the quantifier is, all right? So what we're doing here is we're trying to evaluate this argument. And another thing I want you to notice is that we have X, Y, and Z here. These are all different. Remember, the only reason we have variables is just to show what goes with what quantifier. So it's not really telling you anything. The fact that we have Y here and Z here, that's not telling you anything at all about whether this and this are the same thing, right? There is something that's not G, there is something that's F. Maybe it's the same thing, maybe it's not. The fact that these are Y and Z doesn't really tell you anything. So this says, for everything in the universe of discourse, if it's not F, then it's G. There's something that's not G, so there's something that's F. And sometimes it's a little hard to, get an intuition about these, but this looks to me like it's kind of like modus tollens, right? Which remembers this pattern. Okay, so let's go ahead and see if we can prove this, because it seems like it's valid. So what we should do is try to prove it instead of looking for a counterexample right away. Then if we get stuck, then we'll look for a counterexample for an interpretation that'll show it to be invalid, okay? So one thing about this right away is we're probably going to have to use existential elimination here, which is unfortunately kind of like the hardest rule to use. But we can probably get this if we can replace this with a constant, right, and have not GA. I bet we can get this right in this subderivation, right? And then we'll be able to close this subderivation out and get this by existential elimination, right? So existential elimination, again, it's this rule where you make an assumption. You take an existentially quantified formula, you make an assumption, you rewrite that formula with a constant, replacing the variable with a constant, and you show that something else follows. And if it meets certain restrictions, you can take this out and put it in your main proof. And what this reflects is kind of a pattern of reasoning where we're like, hey, we know that something is not G. Let's just give that thing a name. Let's call it A or something. And we'll use that label while we reason about it. And then at some point, if we can drop that label, show that that label is not critical to the conclusion that we arrive at here, we can pull that conclusion out, okay? So anyway, we're going to assume not GA for purposes of existential elimination, and we're getting that from this line here, okay? Now, the natural thing to do here is to get this in, okay? We're going to use universal elimination on that. And of course, we're gonna use the constant A because we want to be able to work with this, okay? Why did we pick A here? Well, as I said in the slides, if you just pick a letter that's new to the proof, there's 3 restrictions on what you can do with existential elimination. If you just pick a letter that's new to the proof, you're definitely going to meet the first 2 restrictions, okay? So pick a constant. Anytime you use existential elimination, pick a constant that is new to the proof, and you'll be all right. as long as you keep the third restriction in mind, which happens down here. So it's not even really worth trying to memorize what those first two actually are. Just pick a letter that's not anywhere else in the proof above that point, and you'll be all right. Okay? So pick a new letter. So we picked A for existential elimination, so we're going to use A again for universal elimination. Okay? Now, what we need to do here is just kind of recreate, so this, we can get this by existential introduction if we can get FA, right? If we can show that A is F, then we can conclude that something is F, right? So how can we get FA? We can get it by negation elimination, which is always a good way to get a letter if you don't know how else to get it. So my numbers are getting a little too big here. Okay. So we'll assume not FA it's an assumption for negation elimination. Okay. So with not FA, we can get GA by conditional elimination. That's lines 4 and 5. Okay, we could reiterate not GA in there. So not on the assumption of not FA, we got GA and not GA. So not FA can't be right, must be FA. Okay. Lines 5 through 7, negation elimination. So everything in here should have kind of just reminded you of stuff that we've done before. Should be familiar. Now, if something is F, then, if A is F, then something is F. This is a really easy rule to use, kind of like universal elimination. There's really no restrictions on it. You just take any formula and you put any formula that's not quantified, that doesn't already have a quantifier on it, and you can add a existential quantifier and replace the constants with a bound variable. Okay. So that's just line 8, existential introduction, okay? And now we can go ahead and close this out using existential elimination, okay? Which is why we started this whole subderivation, okay? And what we've done is we've shown if we took this existentially quantified formula, we made an assumption where we replaced the bound variable with a constant, we could eventually derive some conclusion. And the restriction that we have to follow here is whatever that conclusion is, it can't have that constant in it, right? So a lot of the time what you wind up doing at the end of the subderivation is using existential introduction to replace the constant. So we get this. So we get our conclusion. There is some Z such that Z is F. That's existential elimination, line 2. You need to cite the line that the original existentially quantified formula was on, in 3 through 9. So a couple things to talk about here. First of all, I picked Z here because Z is what was in our conclusion. You can pick any variable you want, any that you want, whether it's already in the formula or not. It doesn't matter. Okay. As long as you're not conflicting with another quantifier that's already on the formula, which it's not going to happen in this kind of monadic cases that we're looking at. So it could be any variable that you want. The other thing is, like I said, you can't take out of this subderivation the letter that you started with when you started doing the existential elimination. So like we couldn't have done this. We couldn't have got to FA and then taken FA out by existential elimination, and then used existential introduction on this line to get that. That would not have been okay. Okay, even though it would get you to the same place, it's not following the rules of this system. We can't, you can't use existential elimination to get out of here a formula that's got the constant that you started the subderivation with. All right. So there we go.